Hope everybody will be fine by the grace of Allah Almighty in this COVID-19 pandemic. Everybody know we are discussing about the thermal analysis. This is an analytical technique for the analysis of various type of the materials. Hope everybody will be familiar with this type of technique that we already have discussed various aspects of thermal analysis, its introduction, its backgrounds, and one of the technique that is thermal gravimetric analysis. Thermal analysis techniques and methods. There are different techniques and methods employed comes under the heading of thermal analysis, that is thermogravimetric analysis TGA, differential thermal analysis DTA, differential scanning calorimetry DSC, dynamic mechanical analysis DMA, thermomechanical analysis DMA, and thermometric titration. Thermometric titration is also comes in the heading of thermal analysis. In this lecture, we will discuss about the differential thermal analysis DTA. As we already discussed various aspects of the thermogravimetric analysis, now we will discuss about the differential thermal analysis, that is DA. Let's see about the background of this GTA. Leach et al. In 1887 studies clay and mineral by the examination of temperature time curves. The study of the clays and minerals by the relationship between the time and with the passage of time, there is a difference of temperature occurred, then he draws a curve. That is the older or background definition of DTA. Then 1899 some improvement was done in DTA technique. He improved technique by introducing two thermocouples. Thermocouples are the type of sensors to detect the temperature, and with the passage of time the new innovations in different analytical techniques. In this analytical technique, differential thermal analysis also got some kind of innovation. The material and the study and in inert reference are made to undergoes identical thermal cycles. This differential temperature is then plotted against time or against temperature, and the curve plotted is called a DTA curve or thermogram. The curve is plotted is called DTA or thermogram. So the differential thermal analysis got a specific principle that is given by ICTAC. ICTAC is International Confederation for Thermal Analysis and Calorimetry, a technique in which the difference in temperature between the sample and a reference material is monitored against time and temperature, while the temperature of the sample in a specific atmosphere is programmed. So now start with the instrumentation of DTA. So this is a commercial instrument from bottom to top. You can see in this diagram, this is purge 1, purge 2 and protective. These are for the purging, and protective gas is used by these type of knobs. Different types of gases you already discussed in thermogravimetric analysis. Carbon dioxide, helium, nitrogen can be used as the purging gas or the protective gases. This is a hosting device. You can see left of the diagram, this is thermocouple. This is a type of sensor used for the temperature sensing, heating elements, sample carrier, protective tubes, radiation shield, and evacuation system, adjusting screws. The evacuating system is used if instrument this chamber is filled with the type of gases, then with the safety valve, the evacuating system will operative and excess gas will be removed in case of any risk. So in the instrumentation of DTA, various parts of the instrument, for example, we have furnace device for heating the sample holder used to contain the sample, as well as the reference material that provides the data of the sample comparative to the reference material. DC amplifier, that amplifier is used to regulate or amplify the signal that is obtained from the specific instrument. Generally, a low-level DC amplifier is employed. A differential temperature detector, it measures the differential temperature. Mean differential temperature is a difference of temperature between two bodies. And in this case, the sample and the reference. The difference of temperature between sample and the reference material. Furnace temperature programmer used to increase the temperature of the furnace at a steady state. Recorder, this is to record the detailed differential thermal analysis curve. That is also called the thermogram. Control equipment maintain a suitable atmosphere in the furnace and the sample holder. Now, point by point, we will discuss each part of DTA instrument. For example, first of all, we have start with the furnace device for the heating of the sample as well as the reference. In DTA apparatus, tabular furnace is preferred, constructed by appropriate material wire or ribbon wound on a refractory tube. It possesses desired characteristics for good temperature regulation and programming. The choice of the resistant material and that of refractory are decided from the intended maximum temperature of operation and gaseous environment. Because if we got the high temperature of the furnace, then fragile material or any kind of low melting material can create a hurdle in the analysis, malfunctioning in the equipment. So we have to use a suitable material for the construction of the furnace. The dimensions depend upon the length of the uniform temperature zone desired, the size of the sample holder, heating rate, and the cost of the material from which the furnace is constructed. Now we have a sample holder. It is used to contain the sample as well as the reference material. Both metallic and non-metallic materials are used for the fabrication of the sample holder. Metallic material generally include nickel, stainless steel, platinum or its alloys because alloys are much more resistant and these alloys are operative at very high temperature. Non-metallic material include glass, vitreous, silica, or sintered alumina. These are the non-metallic materials. Temperature control. The basic element required are sensor, control element, and heater. Control element governs the rate of heat input required to match the heat loss from the system. There are two methods are used for controlling the temperature. On-off control. On-off control is if the sensor signal indicates that the temperature has become greater than the point, the heater is immediately cut off. It is a program type control off. It is a control that is uh, covered by a knob of the instrument. Proportional control, the heat input to the system progressively reduces as the temperature approaches the desired value. Now the temperature programming. It transmits certain time-based instruction to the control unit. The simplest device is to use a variable speed motor-driven auto transformer which gives a power input to the furnace that is proportional to the rate of the movement of the drive mechanism. It can archive the linear rate of heating or cooling if the auto transformer is driven in a non-linear fashion using a special cam drive. Recorder. Signals obtained from the sensor can be recorded in which the signal trace is produced on the paper or film by ink, heating, stylus, electrical writing, or optical beam. There are two types of analog recording modes are available in the modern type of instrument: deflection type and null type. In deflection type, the recording pen is moved directly by input signal. Null type, the input signal is compared with the reference or standard signal and the difference is amplified by DC amplifier and used to adjust the reference signal through a subwoofer until it matches the input signal. Thermocouples, thermocouples are the temperature sensor. They are the temperature sensor in most of DTA and differential thermal analysis equipment as well as other thermal analysis equipments or instruments. The voltage signal produced between the two heterojunctions of the thermocouple depend upon the temperature difference between these two junctions. The following point has to be considered while selecting the thermocouple as the temperature sensor: temperature interval, thermoelectric coefficient, chemical compatibility with the sample, availability and the cost, chemical gaseous environment choose, and reproducibility of the EMF versus temperature. EMF is the electromotive force, that is a driven force to drive the potential. EMF versus temperature curve as a function of thermal cycling. Above 1100 degree, one should use a thermocouple made from pure platinum or platinum rhodium alloy wires, because some materials have high melting points, high flash points. So we have to use very high temperature bearing sensors, mean thermocouples we have to use. Thermocouple fabricated from refractory material like tungsten and rhenium and inert gases are in vacuum for temperature up to 2100 degrees centigrade. Control environment. The cooling system is considered separate from the temperature program because in most instruments cooling is completely independent of heating. Now, from the instrumentation point of view and how we load the sample when we do the analysis using the differential thermal analysis technique, the sample and the reference are placed symmetrically in the furnace. The furnace is controlled under a temperature program, and the temperature of the sample and the reference are changed. During this process, a differential thermocouple is set up to detect the temperature difference between the sample and the reference, because the differential thermocouple is always used for the difference of temperature between two objects. Differential means between different objects. Also, the sample temperature is detected from the thermocouple on the sample site. This is a block diagram or DTA instrument. You can see in the block diagram two pens, one for the sample, other is for the reference. The blue part of this diagram represents the furnace, and the line that is positive on both sides, one is attached to the reference, other is attached to the sample. This is a thermocouple. This is a temperature sensor that measures the difference of temperature between two pens, mean the reference pen and the sample pen, and a line is drawn between the positive lines. One is the difference of temperature between two objects, mean the reference and sample, and one is for the sample temperature. As a result of DTA analysis, we get a curve, that is temperature time curve, that also called the thermogram or DTA curve, that give us the data that we got from the DTA analysis of any particular object. In this case, we have, for example, graph A and graph B. Graph A shows the temperature change of the furnace, the reference and the sample. One is solid line, other is dotted line, and number 3 is the Higgs zigzag line. The solid line is for the reference furnace temperature. The dotted line is the reference temperature time behavior line, while the zigzag line is the temperature time relationship of the sample under observation. Graph B shows the change in temperature difference delta T against time detected with the differential thermocouple. Delta T signal is referred to as DTA signal. That DTA signal gave us all the information about a particular sample under investigation. That signal is also called the thermogram. In graph B, we have a melting of a sample, that is endothermic phenomena. And after some passage of time, it comes to maxima, that is called the exothermic phenomena. With the passage of time, we get a graph between graph between temperature and the time. So then in this all the type of DT analysis, usually alpha alumina is used as a reference. When the furnace heating begins, the reference and sample begins heating with a slight delay depending on the respective heat capacity and eventually heat up in according to the furnace temperature. You can see from the figure. Delta T changes until a static state is reached after the heating begins, and after achieving stability reach a set amount compliant with the difference in heat capacity between the sample and the reference, and the signal at the static state is known as baseline. You can see from the figure the difference of two lines between the sample and reference temperatures. When the temperature rises and melting occurs in the sample, for example, the temperature rise tab as shown figure A, and the delta T increases. This arrow showing the melting point of the sample. When the melting ends, the temperature curve rapidly reverts to the baseline. For a moment, it comes to the baseline, then again it rises up. At the point, the delta T signal reaches the peak as shown in figure B. From this, we can detect the sample transition temperature and reaction temperature from the delta T signal, that is called the DTA signal. In graph B, the temperature difference due to the sample's endothermic change is shown as the negative direction, and the temperature difference due to sample exothermic change shown as the positive direction. So we have two directions. That is, one is positive, other is negative. Negative also called the minima, and positive also called the maximum. If we show a minima, then this type of effect called the endothermic. If we show a maxima in the DTA curve, this is called the exothermic phenomena. In endothermic, heat consuming reaction include dehydration, releasing of adsorbed water and water bound in the structure as H2O or OH. Structural decomposition may be occurred. Melting, evaporation, and sublimation reaction may be occurred. Structural transformations, magnetic transformation, demagnetization of ferromagnetic substances, and maybe reduction occurred. You can see two different examples of exothermal, thermic, and endothermic phenomena. If heat comes from system to the surrounding, it means it absorb the heat. This is called the endothermic. If the heat from system to the surrounding, then this is called the exothermic. Mean heat from system to the dissipate to the surrounding. In this case, heat is released. Heat release is exothermic phenomena. Heat absorb is endothermic phenomena. In exothermic, heat releasing reaction includes oxidation, including combustion, process of freezing, reconstruction of a crystal structure, structural transformation like cooling. In DTA, the temperature of a sample is compared with that of inert reference material during a programmed change of a temperature. The temperature should be the same until the thermal event occurs, such as melting, decomposition, or change in the crystal structure. In an endothermic event takes place within the sample, the temperature of the sample will lag behind that of reference and minimum will be observed on the curve. As this is already explained, there are two behavior of curve shown in the former figure. One is minima, other is maxima. If there is a minima, this is called the endothermic. Is a maxima, this is called the exothermic phenomena. On contrary, if an exothermic event takes place, the temperature of the sample will exceed that of reference and maximum will be observed on the curve. For example, we have a graph that shows a TGA curve and DTA curve. The area under the endothermic and exothermic related to enthalpy of the thermal event delta H. At the temperature range, you can see from the figure 500 to 700, there is a change in mass occurred on TGA curve, which corresponds to the dehydration of choline, and this dehydration shows up to DTA curve as endothermic. You can see in DTA curve, this is as minima at 952 980 degrees centigrade second DT effect occurs, that this effect not occurs on the TGA curve because that is related to the mass. But in this case, we have to see two different phenomena. One is exo and one is endo. Endothermal thermic phenomena is observed at 500 to 700, while in case 900 to 950 to 980 degrees centigrade we see a maxima. This maxima is exothermic. This is because this event corresponds to the recrystallization of dehydrated kaolin. This recrystallization process is exothermic due to maxima shown in DTA curve. TGA DTA mode can be used to determine melting points, glass transition temperature, crystallinity, moisture, volatile content, thermal and oxidative stability, transformation temperatures. Following are the factors which influence the DTA data. DTA data, as a result of the curve, we got a data. Either it is maxima or minima. So various factor effects on that data. Furnace atmosphere, sample arrangement, thermocouples, heating rate, reference material, amount of sample, and preparative factors. For example, first of all, we discuss about the furnace atmosphere. Different purging gases are used during DTL like carbon dioxide, nitrogen, argon, etc. As we see in the instrumentation of the DTA, where purging 1, purging 2, and protective gases. A circulating atmosphere can cause a peak shift. For example, the temperature of decomposition of carbon dioxide to calcium oxide and carbon dioxide can be lowered by elimination of carbon dioxide. Using ambient static air as the furnace atmosphere, the GT data can be affected by chemical reaction that occurs between air and the sample. It may be a reaction occurred between the sample and that air, maybe oxidation occurred as a result of the reaction of air with the sample. Its gaseous decomposition products are the sample odor, its oxidation or the contamination of platinum container with the sulfides. Platinum sulfide may be formed. Changes in the reaction mechanism of the sample caused by accessory gases. That is, the peak shift of dehydration reactions such as that of gypsum by difference in partial pressure of water in the air. Sample arrangement may affect the DTA data. Nickel blocks, platinum containers, are crucibles, and ceramic flasks are the most frequently used sample holders. DTA peak decrease in proportion to the increase in the heat conductivity of sample holder materials. The use of ceramic sample holder therefore results in especially clear DTA peaks and especially large time lags in the peaks. That is higher peak temperature than with nickel or platinum sample holder. So ceramics have advantage over the metallic type of sample holder, platinum or nickel based. In most DT operators, thermocouples out of platinum rhodium or nickel chromium with a wire diameter between 0.1 and 0.3 millimeter are used. Thermocouples are the sensors for the temperature sensing. Thermal effects are increased when the heat that is absorbed by the thermocouple, the heat capacity of the thermocouple decreases. The arrangement of the thermocouple relative to sample also influences the recorded DTA curves. The most favorable position of the thermocouple will be in the center of the sample and of the inert material. DTA of high resolution, of which the peak temperature lie close to the thermodynamic equilibrium temperature, can only be attained at very slow heating velocities. It means the heating rate should be slow. It must not be a rapid heating rate. At very rapid heating rate, for example, greater than 50 degree per minute, the insufficient resolution of peak lying close together, and these are only allowed in cross case of determination where there is a difference of heating uh, temperature difference. Reference material. The reference material for the measurement of temperature difference can be inert or active. Inert substances have no heat changes in the temperature range less than 1100 degrees. Its heat conductivity and its specific heat should be similar to the heat properties of the sample. If we have a similar heat conductivity and same aspects related to heat conductivity of sample and the reference, then we will get a very fine DTA data to elaborate the results obtained by DTA after DTA analysis. Suitable reference material for silicates, especially for clay minerals, are alumina or burnt Colinite. Amount of sample is also an important role in DTA data elaboration, DTA data gathering. The amount of sample used in DTA lies between 0.3 milligram. The amount of sample determines how long heat will need to cross the whole sample. If the sample is too large, a remarkable difference between the temperature of sample holder and that of sample will occur. When extremely small amounts of sample are heated, there will be a great danger of heated substance not being represented for the whole sample. It means it will not a representation of the whole sample that is under observation. And lastly, the preparator factor also affect the data of DTA after running the sample by DTA instrument. Beside the operator factors like heating rate, furnace atmosphere, thermocouples, and beside the properties of substance to be analyzed, packing density, grain size, these also depend upon DTA data. The preparation of the sample may have some influence on the appearance of the DTA curve. The crystal structure of quartz will, for instance, be destroyed when the ground too long in a gate mill. If the crystal structure is disturbed, then we will not get accurate data by DTA. We cannot have a surety if we have disturbed sample put into the DTA instrument. That means by increasing time and intensity of grinding, the defect character of crystal will increase too, so changing the physical property of the crystals. The dehydrogen behavior of clay mineral is influenced by the humidity of the air of the laboratory and so on. And lastly, the applications of the DTA in our routine laboratory or quality control labs. DTA is a type of the thermal analysis. As a result of you get the thermal curves. So this DTA thermal curves can be used to determine the order of the reaction, mean the kinetic studies, the physical phenomena, and the kinetics with which the reaction will taken place between different molecules compound and provide the information required to construct a phase diagram for the material. As we already discussed about the phase diagram in TGA lecture. Qualitative identification of material is done by comparing the DTA of the sample to the DTA thermal curves of known materials. DTA thermal curves are a fingerprint for the materials. So this is also identification technique. Mean you can do the qualitative analysis by DTA instrument. DTA can be used for characterization of engineering materials for the determination of the structural and chemical changes occurred during the sintering, fusing, and heat treatment of alloy to change microstructures, identification of different types of synthetic rubbers, and determination of structural changes in the polymers. DTA is widely used in pharmaceutical and food industries. In pharmaceuticals, especially, morphology is most important. The morphostructure or crystalline structure have different efficacy. The same compound, they have a different crystal structure. If different morphology, its efficacy will be different. DTA may be used in cement in chemistry, mineralogical research, and in environmental studies. DTA curve may also be used to date the bone remains or to study the archaeology material. That is very important application of DTA, from which you can calculate in the lab the age of any fossil fuel, age of any old debris. We can aging with the help of DTA. We can calculate the aging factor. So this all about the DTA, differential thermal analysis, and these were the applications. So thank you very much. Now anybody have a question, that put on the chat box, I will answer all these questions. Again, thank you very much.